let's check back in with Lily and get another question answered.
This one asks to convert this equation into standard form.
So I guess this could be a math or a science
Yeah,
question.
I love scientific notation.
I love
So-
the crossovers.
This is written, this question. Oh, my pen is being a little weird. I'm going to go ahead and copy that down. It was 4.22715 times 10 to the 8th power. And this is in scientific notation. And I know Sam had talked a few times about why we use scientific notation and why it's really
me too.
important in science. And okay, Becca too. She wants her
You
credit.
give them credit.
I had to get credit.
Yeah. Because a lot of times in science we work with really big and very, very small numbers that it would be very hard to compare or imagine the scale of how big or small those numbers are without something to kind of, I guess, put it in a similar form and to really be able to compare those. So again, this is in scientific notation, which in scientific notation we typically have just the one decimal place after the ones unit. Now, it's actually pretty easy to convert this into standard form. All we're doing is we're going to write this basically without this decimal here. And if you think about this, we're really just multiplying by 10 to the 8th. Well, 10 to the 8th is just a 1 with 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th would be about 100 million. So when we're multiplying anything, like if I did 4.2 times 10, we could just move the decimal place over 1, and we could say that this is 42. If I did 4.2 times 100, we could move this decimal place over to the right 2 times, and there's nothing there, so we would do 420. And we could just continue this. And again, in scientific notation, if I want to convert this, really what we're saying is 4.22715 times 100 million. So all we would need to do is take that decimal. I'm going to rewrite this again so we have some space. And we're going to move this decimal place over 8 times to the right. So 1, 2, 3, 4, 5. And again, we're out of numbers here, but everything you could actually consider that there are an infinite number of zeros past here, past the decimal places. So we had 5, 6, 7, 8. So just add 3 more zeros here. And then you get 4, 2, 2, 7, 1, 5, 0, 0, 0. Throw some commas in there so we can actually kind of see what this number is. So 4.22715 times 10 to the 8th power in scientific notation is going to be 422,715,000, which is something that you're just more familiar with seeing like on a day-to-day basis. But again, if this number got even bigger, it would be really hard to kind of understand the scale of that number without scientific notation.
When you talk about moles
Yeah, Avogadro's number.
and times 10 to the what, 23rd power?
23rd power.
Huge
600
numbers.
sextillion.
Yeah,
Whatever
that's
that
a lot of
means.
zeros.
Well, so when we talk with students about that, it's so hard to say, okay, so what's the difference between a billion and a trillion, let alone a sextillion? So one thing we did in class was we looked at, this guy had calculated if you were given $600 sextillion on the day you were born, and you lived to be 100 years old, and you spent $1 million every second of your life, you would have only run through 1% of the money that you had by the time you died.
Wow, I wish I was born in that situation.
A 600 sextillion?
Wow.
Isn't that cool? So I think those
you
types
go.
of exercises help us
Yeah.
wrap our brains around them.
For real.
But other than that, you can't, without scientific notation and getting a sense, oh, well, 10 to the 23rd is significantly more than
Right.
10 to the 9th, for example.
Right.
And then having a discussion about the difference in those numbers is really difficult.
It's very tough.
Crazy.
Crazy stuff.